All right, today we're going to talk about generating equivalent ratios. So equivalent ratios are ratios that express the same relationship. We talked about this a little bit yesterday, but for example, we have 1 to 2 and 2 to 4. Those are equivalent ratios because they express the same relationship. If we have 1 square to 2 circles, okay, I can also I can double this ratio, or both of the parts of the ratio. So now I have 2 squares to 4 circles. This part was my original. I double it, and I have now 2 to 4, which is the same as 1 to 2. Okay, so just like with fractions, we can write equivalent ratios by multiplying or dividing both the numerator and the denominator, or the 2 parts of the ratio, by the same quantity. Okay, so if I have a ratio of 6 to 7, okay, if I multiply both the 6 and the 7 by 3, okay, I have 18 to 21. 6 to 7 and 18 to 21 are equivalent ratios because I multiplied them by the same number. Okay, this works if it's written in a different way. So if I have the ratio of 5 to 9, okay, written with that colon instead of that fraction bar. If I have 5 to 9, if I multiply this 5 and this 9, if I multiply them both by 2, that will be equivalent. So times 2 times 2, 5 times 2 is 10, 9 times 2 is 18, 10 to 18, that is equivalent to 5 to 9. Okay, multiplied by the same number. Same thing when we're dividing, okay, or if we divide. So if I have like 10 to 2, okay, I can divide both 10 and 2 by the same number. In this case, I'm going to divide them both by 2. 10 divided by 2 is 5, and 2 divided by 2 is 1. I get 5 to 1. So 10 to 2 is equivalent to 5 to 1. Okay, just like with fractions. We already know how to do this with fractions. Okay, so on your work for today, you're going to be asked to find, say, 3 ratios that are equivalent to a given ratio. So if I asked you to find 3 ratios that were equivalent to 10 to 2, 5 to 1 would be one, 20 to 4 would be another equivalent ratio, 30 to 6 would be another equivalent ratio. Okay, see, I just multiplied, in this case, the 10 times 3 and the 2 times 3. Here, for this one, I did 10 times 2 and 2 times 2. Okay, so you're just multiplying by the same number. It's that foo, that form of 1. Okay? So here we're going to see how ratio tables can help us organize our equivalent ratios. Okay, so a ratio table just puts the ratio in a table format, and then we skip count along in order to find equivalent ratios. Okay, so if, in this case, if the ratio of cookies to children invited to a party is 8 to 4, use a ratio table to determine how many children were invited if there are 48 cookies. Okay, so we're starting out with 8 to 4. Now that's not even the simplest form ratio. We could go simpler form, but we have 8 to 4. So if I take this 8 and I multiply it times 2, I'll get 16. And if I take the 4 and I multiply it times 2, I get 8. Okay, so basically I skip counted here. I went 8 to 16, so 8, 16. And then if I kept with the skip counting, I would do 8, 16, 24. So 8, 16, 24, 32, 40, 48. Okay, for the 4, if I skip counted 4, 8, 12, 16, 20, 24. Okay, so we can see that from the 8 and the 4 to the 16 and 8, I'm multiplying times 2. If we go another jump here, 8 times 3 is 24, and 4 times 3 is 12. Okay, so I'm taking that first number and I'm multiplying it by the same number for both parts of the table to get equivalent ratios. Okay, just like in the last slide there, we talked about multiplying by both numbers by the same thing to get equivalent number or equivalent ratios. Here we're doing the same thing, just in table format. Okay, so determine how many children were invited if there were 48 cookies. So we look in our cookies section here, our cookies part of the table, and we find 48 is right here, and the number that goes with 48 in our ratio is 24. So if there were 48 cookies, then that means 24 children were invited to the party. Okay. Let's look at example number 2. If the ratio of sunny days to cloudy days is 15 to 12, how many cloudy days are there if there are 5 sunny days? In this case, we're going to divide both of the numbers to determine our answers. So we're going to use a ratio table. So sunny days was 15, cloudy days was 12. Okay, so since we need to get from 15 down to 5, we are going to, instead of multiplying, we're going to divide down. Okay, so I'm going to go from 15, and then I want to get to 5. So I need to figure out, how did I get from 15 to 5? I divided 15 by 3. So then if I divided 15 by 3, I need to divide 12 by 3. Okay, so 12 divided by 3 is 4. So right there, I didn't really need much of the table here at all. I could just figure out that if I divide 15 by 3, I get 5. Divide 12 by 3, I get 4. So if there are 5 sunny days, there are 4 cloudy days. Okay, if I wanted to fill in this table to figure out some more information, I could then go ahead and skip count. So if I did like 5, 10, 15, 20, I could also fill in the 4s as 4, 8, 12, 16, which gives me some more information here. Okay, let's look at example number 3. So using the ratio above, so we're still using that 15 to 12. How many sunny days would there be if there were 48 cloudy days? You must use a ratio table. So here we need to get from those 12 cloudy days to 48 days. Okay, so we can, since 48 is a multiple of 12, we can skip count. So let's do 12, 24, 36, 48. Okay, I could keep going to 60. Okay, but I don't need to because I got to that 48. Then I skip count by 15. So 15, 30, 45, 60, 75. Okay, so we're looking for 48 cloudy days. That's right here. And we look at the number that is associated with the 48. That is 60. And so when there are 48 cloudy days, there are 60 sunny days. So that's how we can use ratio tables to help us define equivalent ratios. We're just, once again, multiplying our numbers by our ratio by the same number to get equivalent ratios.